Welcome to our podcast for our introduction to science notebooks. This video has been created by your sixth grade science teachers, and this is Mr. Windmiller, and I will take basically kind of the first half, part one of this introduction to science notebooks, and Mr. Cora will be doing part two. First thing here let's talk about is what is a science notebook? Well, basically, it's a compilation, a collection of entries, and you can take a look at this at any time and basically see what we are doing in the classroom. And it should have entries on a daily basis, whether that be adding an investigation, putting in a rubric, a quiz report, or even adding vocab on a weekly basis at the back in their glossary. We will use two notebooks. We'll have a notebook that we use during the first semester, and then at Christmas time we will switch and start a new notebook for our second semester. You'll notice each notebook is unique to the student. So if you have a neighbor, someone else that you know that is in class, whether it be on Team Bold or Team Lightning, there will be similarities, but there's going to be differences because of what each student has as an experience in the classroom. And the notebook is the centerpiece of our science classroom. It's not the textbook. Our textbook is a great resource, but it is not our number one piece in the classroom. The point of a science notebook has many uses. It's going to help your student develop, practice, and refine their science understanding. This is something that students have to consistently work on. Science is a different way of thinking, and we want to encourage kids to broaden their thinking in science. And it's going to enhance their reading, their writing. We do a lot of math. Math and science, of course, go together, especially in some of the genres that we'll do. And finally, communications. The kids are going to have to stand up in the classroom. They're going to have to tell others about their results. That is a big thing in science. We do not do an investigation. Scientists don't do an experiment and hold those results. They share them. Who uses science notebooks? Well, there's some very famous people, of course. And Galileo Galilei used that notebook in order to put down his findings in proving that the Earth orbited the Sun. Albert Einstein, of course, you know who he is, and here's an example of what he put down for his theory of relativity. Thomas Edison, of course, drawings for light bulb, phonograph, motion picture cameras, and you can see an example here of one of his notebooks. And if you look in the top right hand corner here on his notebook, 1880. So obviously notebooks have been used for a very long time. So let's start out first and go through our tour. I have some introductory things that I'm going to go through, and then Mr. Cora will go through basically the nuts and bolts of the notebook. And we're doing this so that you as parents understand at home. So when your child comes home and it says for homework that they have claims and evidence, you're going to have an understanding of the expectations for that part of the notebook. Okay, first thing is the cover. The kids should have their name, first and last, and their period on there. So if they are missing that, please help facilitate them to get that on there. That helps Mr. Cora and I when it's time to grade something. We can tell whose notebook it is very quickly. And we have some cabinets and crates and different things that we keep the notebooks in. It's going to help them find it quicker. And then obviously if they leave it somewhere, it's going to have their name on it so we can get it back to the owner. If they do lose that notebook, as many of you have already seen with our lab contracts, they are going to have to reproduce that notebook. Okay, title page is going to be on page 1. This is a page where the kids can put their name, put our name, put their class period, draw a picture, put a sticker. The title page is kind of the one place they can go doodle, draw, write, color. Basically, this is their page. So if you see them doing these things on the title page, which is the very first page, that's okay. The rest of the notebook needs to be organized and structured in a certain way. Table of contents. We have set aside pages 2, 3, and 4 for their table of contents. And we've started to put some of these things in there. We have Page 5 is our notebook guide. Page 6, observing and comparing. And these are just some examples of some things that we also will be adding here. Page numbers may or may not coincide, but you get the gist of it. They should have the page number to the left of the margin line. That margin line is going to be that line that runs right along the left-hand side of the page, and then the activity or the name should be to the right of that line. We will work on and impress on the kids that there are certain things that go to the left of the line and there are certain things that go to the right. And if it's not organized correctly, then there is a possibility of losing some points. Okay, Science Notebook Guide. Excuse me, this is going to be an important thing on page 5. We will help the kids through the first few investigations, but after we start to set forth some habits in how we do our notebook, we are going to turn the kids loose. And if they have questions, a lot of times we're going to make them go here to page 5. So if they have a question about the prediction, they're going to have to read and see examples that we have given them on this page. As you look at this, you can see there are some areas that are italicized. The great thing about the notebook, there are a lot of sentence starters on here. So as far as how to start the sentence, that's taken care of. When they do a prediction, it needs to start with I think or I predict. And it must have the word because. They've got to fill in everything in between. Now, this is just a quick glimpse at the parts of the notebook. You can pause this if you'd like and read it. But this is a lot of what Mr. Cora is going to go through here as he moves into part 2 of this podcast. The general order of the notebook will go in this order. So you start with purpose, prediction, procedures, data, claims and evidence, conclusion, reflection, signature. And this will be something that typically is over a 3-day period. The format of the claims and evidence you can see here is a T-chart. So they will make a T in their notebook. Claims on the left, evidence on the right. These are in all investigations. Okay, page 6 has an observing and comparing guide. Again, this is a resource for them to show, all right, we're stuck, and a lot of times it may be just the first couple words that get them going. So the notebook is structured so that that is taken out. They can go here. So just even to put I observed or I noticed. Using box and T-charts, and we will have gone through this with them already the first few days, and they can use these also to organize their thoughts. A box and T-chart, very simply, is great to use when you're comparing objects. Inside the box goes what's the same, and the T-chart is where they put their differences. Okay, line of learning. This is an important one. Each chapter will have its own line of learning, and it's basically the big idea for the chapter. So for instance, this is chapter 1. What does it mean to think like a scientist? And students at first are going to get this question before we have even touched the chapter. Haven't read anything. Usually after a quiz, they'll turn their quiz in class, and then they'll have a line of learning waiting on them if we finished a chapter. So they're going to answer this before we do anything in the book, which might seem backwards, but we want to use prior knowledge as much as possible. When the students are going to be writing an investigation, they need to use prior knowledge. What do I already know about this? Have I done this before? Have I done something similar to this before? And then they're going to use that knowledge. So even here on the line of learning, as you can see, the first example, August 1st, obviously not in school at that point, but they're going to put the date, and they're going to write an answer. A scientist thinks by using the scientific method. When they do a line of learning, it should be in sentence form. It should be a minimum of 1 sentence. If they can write more, we're going to encourage them to write more. In the notebook, we don't need to write and write and write, book upon page. Format is important because the format drives the thinking. So you're going to maybe wonder, why are they losing points because they didn't do it this way? Well, the format drives thought. So we're going to really impress upon them that the format is important to begin with. But they need to put down their thoughts. The one thing they can never do is put, nothing happened, I don't know, I'm not sure. Those don't work. They got to put something. As you can see, this student moved. We went about a week. We did an investigation. We did a couple activities. We read out of the book. watched a video, whatever it was. So now, as you can see, their answer has changed. We may revisit a line of learning 5, 6, 7 times. So you're going to see on the page 5 or 6 or 7 answers, dates, and then lines. It's a line of learning because each time they answer, they're going to put a line across that's going to separate their answers. Hopefully, over that time, they're going to add information, something that maybe I said in class, maybe something that they read in the book, maybe some vocab word they added to their glossary. In this example here, you can see the student started to use words. An inference is something that we'll talk about in class, and that is a vocab word. So the line of learning is important. It drives, it's our big question, our big idea over that chapter, and it's going to be something that we revisit time and time again. At the beginning of each investigation, we will give the kids what's called a success guide. This is not something right off the bat that is mandatory, but it can be something that we make mandatory for individuals. And as you look at this screen, you can see it goes through each of the parts of the notebook. It shows on the left-hand side, okay, what am I going to be graded on? For purpose, we're going to check, did you copy the question? For prediction, did you start it with I predict or I think? Did you use the word because? And is your statement include a possible explanation? So the left-hand side is the rubric. It's what the kids are going to be graded on. So they should use this as a checklist. If they can go through and check each of these things off, assuming they do it correctly, then they should be able to get all the points. The right-hand side of the success guide is going to give them some hints as to, okay, what else do I need to do? What do I need to make sure I do? And it's going to, for instance, if you look at purpose, did you title the investigation? Did you put it in the table of contents? Did you put down the date? Do you have a label in the margin? And that's going to be to the left-hand side of that margin line. So as you read down through, you can see there are quite a few hints, reminders about each of the parts. Many times these will be the same thing over and over and over again. There won't be a lot of changes. Every once in a while there may be something unique about an investigation, and therefore we may tweak it a little bit. But most of the time you're going to see a lot of the same things. And this is our success guide for our first investigation of the year, NASA's next shuttle. We will be using My Big Campus. That's something here in the next basically the first couple weeks of school that we will begin to use. It is an online, kids can use their iPods. There's an app for that, and it's free, whether it is Apple or Android. You can obviously get to it through a computer, and we'll use this quite a bit. And a lot of our resources, success guides, and so forth are going to be available on there. So as I mentioned, even if they are on their iPod at home, if they've got a Wi-Fi connection, they can download that My Big Campus, and they can work through resources to get to the success guide.
Thank you, Mr. Woodmiller, for doing the first part of the podcast. I am Mr. Cora, the Team Lightning Science teacher, and I will be taking you through the remainder of the podcast, looking at the actual first investigation and what goes into an actual investigation. We'll start out with looking at this first investigation. It's important that the page numbers be on every single page. They should have already taken care of this earlier in the year, and if they haven't done this yet, you'll want to remind them to get those pages numbered so they don't have to worry about it later. We'll then move on to always writing the title. This goes on the first page of each investigation. It also should be found in their table of contents and list which is the first page of that investigation. After they've put the title down, we always then move on to the purpose. The purpose is typically provided, although there are a few exceptions to this case when we're having investigations that are very open for what the students want to investigate. And this is always what guides the whole investigation as to where it is going to go and what they're going to do. In this case, it says which adaptation allows the space shuttle to fly the furthest, as the scientists are going to be looking for ways to make a paper airplane glide further because they have already seen that the space shuttle typically glides to a landing. They then will have to write their prediction. And the initial prediction is what the scientist thinks is going to happen. And predictions are never graded for correctness because this is what they first think is going to happen. as Mr. Winmore said, they can't say, I don't know, or I'm not sure, or I have no idea. Those are not acceptable answers. They have some sort of idea of what's going to happen, they just need to say what it is. It's always formatted in a certain way as either I predict because or I think because. And it's really important that they always start out with that because we have the word because, which actually is the most important word and shows up throughout all of our investigations. And the reason why the because is extremely important in a prediction is it turns it into a prediction instead of a guess. They have to back it up with something and explain why they think this would happen. It doesn't have to be anything incredible. They don't need to be able to cite any sources or anything like that, but they need to be able to explain what they think will do or what they think will happen when they do that part of their investigation. After the prediction, we then typically move on to the procedures. The procedures, of course, start out with labeling in the margin for which section it is, and then they start by listing all of the materials. In this case, the materials are listed here as typing paper, paperclip, balloon, meter sticks, and string. They'll be given a list of items that we will be providing in the investigation, but sometimes they may need to have some other simple things. We always encourage them to think of things that they can easily get a hold of and to let us know and see if we maybe have some of it laying around in our labs as well. Typically, though, investigations, we give them everything they will probably need for it. Then they'll actually have procedures. In this case, we actually gave them a copy of procedures, as you can see here, and had them glue it in because it's the first investigation. But when you're looking at procedures, which they will be writing then for for most of the rest of the investigations, there's several things that make up good procedures. In this case, we want to look at the idea of a fair test, which means that you're only changing one thing at a time. You also want to make sure that they have sequence words to help start the directions so that they're actually showing which things are going to occur first, second, third, next, then, finally. Those words help to trigger what's going to happen and helps them to make sure they're putting things in the correct order. They also want to make sure to include what measurements and observations they may need to take. This helps them to think about what they're going to do when they're actually in the lab so they don't go in and have to try to figure it out once they get in there because the lab period runs by very, very quickly, they will find at their first investigation. They also need to include how they'll make their observations if there's any special instruments they may need, such as a triple beam balance or some other device. And of course, they need to have the procedure so that someone else could follow them. Because a good scientist wants somebody else to be able to always do what they have done before to be able to test their experiment. After they've written procedures, they then move on to the data table. Notice it's already labeled in the margin, they've also added a date. The entire data table is always set up before the beginning of an investigation. In this case, we actually set up the data table as a class so they can have one good design to begin with, and we can help them out with it, and then as well as you can help guide them to set up a good data table. Data tables that are set up well always start out with using a ruler to make nice, neat lines, and this helps them out to make sure they have enough space to be able to write things down. Notice that we've used the lines inside the notebook in order to help guide that. You can also see that they have a place for all of the data to be recorded, and it's large enough that they can record the numbers easily. Most of the time, the numbers they'll record have 3 to 4 digits in them, plus the unit, and so we want to make sure there's enough space for that. You can also see that there's enough space for the number of trials they've planned. They've already planned to do this 3 times, so they need to make sure that they have 3 spaces for it. They also planned on taking an average, so therefore the average line is also included in the data table, so they remember to take care of that after they get done. Personally, I've always used the data table to help check to make sure that I have everything I need when I walk out of lab at the end of the period. Now when we fill in the data table, you can see here I've put some data into our data table. And there's some interesting things I want to point out. First of all, you can see everything's neatly written down. We're not looking for the best handwriting in the world for it, but it does need to be readable that they can at least understand what they wrote down. Also notice the mistake here that occurred. The mistake, of course, was written in pen, so they cannot erase it because there is no erasing in a science notebook. Instead, they crossed it out with just a single line to leave it visible. In science, we really like mistakes, and we will not penalize if they make a mistake on something and cross it out. We'll actually penalize instead if they make it so that it cannot be read by crossing it out 2, 4, 5, 6, or even 1,000 times as some of them may try to do with a pen. So it's important to make sure they leave those mistakes visible. Also notice there are units for every single measurement. And that is extremely important because we want to make sure that they are putting the correct units down so that they are measuring the right thing. Because if they put down nothing there, we have no idea what they're actually talking about, and it could be a miscommunication there. After we've made that, we actually made a graph this time. Graphs are not required for every investigation, but I wanted to make sure to go over it so you could see how one is set up for what we're looking for in our science notebooks. Granted, we don't use grid paper for this, but we can get a very nice graph just using a ruler and the lines already in the notebook. Starting out with, we can see the date has been included, and you hopefully have seen the date has incremented as we've gone along. Every time that we work in our notebooks, we always want to make sure we put the day's date on it. The graph is made large enough so that anyone can easily see the results. And if you look in this case, there's 10 lines on there, so it's easy to do the math to figure out which one as well. You can see the scale is equally spaced so that the graph is not misleading in any way, and of course starts at 0. The axes have also been labeled so that anybody can see easily what is going on with it. All the lines on there have been made with rulers, so that way it's actually very simple to see and it's a nice clean graph. When they're making graphs, they are allowed to use a pencil so if they make a mistake as they're trying to lay it out, they can erase that mistake. Of course, when they're making a graph too, it needs to be in color. Color always helps out to be able to see what the differences are. The color choices are always the choice of the student. However, if there's an obvious color, we always encourage them to choose that. And of course, with colors, you also need to then add a key to show what the results are displaying. And it's very important to make sure all this is included there. Again, for this first investigation, we did this entirely with the class, so they are going to be able to do this very easily and have a great example in their science notebook. Ask them to share it with you so you can see what they have. The next thing after that then is the claims and evidence. This is a standard part of every single investigation and is a frequent part of all of our quizzes and tests. The claims and evidence, though, is one of the most often missed assignments, too, we find, as being a homework not done. If they don't do their homework in their investigations, we do still have penalties that show up. Even though investigations are only graded once every 3 or 4 days, we do check them every single day to make sure they're following through with the progress. If they don't complete the assignment, it's actually going to be very detrimental to them as they're going to have to complete it before they can go on to the next step. And so even with a not done stamp on the assignment, it still needs to be completed so that they can do the next step successfully, and they'll actually find it's much easier to do if you do the assignment at the right time. A not done stamp, though, is unfortunately also going to mean no credit. According to the 6th grade syllabus, we do not accept any late assignments, so therefore we cannot accept any parts of an investigation as being late either. This student luckily did complete their claims and evidence, as we can see here. You can see the claims and evidence starts out as a T-chart, and it is always formatted in this way with the claims and evidence labeled at the top. The T-chart is a very handy way to help make sure that they have both parts written down, and it makes it very easy to read. If they try to put them into paragraph form, they typically find that they don't get the right results and they miss something that was very obvious to them. They knew the answer, they just didn't communicate it clearly. You can see in this case the claims always start with I claim or I know. Either one of those responses works. And of course the evidence begins with I claim this or that because or I know this or that because. And they choose the appropriate one for the situation and which one just flows more naturally to them. For each one of these you can see that it has been numbered. In this case there is just one claim and therefore has to be one evidence because every claim needs an evidence. In this case, we can see that they are claiming that the flaps allow the plane to fly further, which they saw in their results, and their evidence is then backed up with quite a bit there. You can see that whenever possible, they've included the quantitative or numbers and measurements inside the evidence. If they can find a number to help support their answer from their investigation, it should be here. The evidence needs to be taken from their investigation as well, so they should be able to point back to some observation or something else in either their procedures or their data table to support their evidence. And it needs to actually be something specific, especially in this case like a number that they can say the average was the highest. After they finish with the claims and evidence, they then always move on to the conclusion and reflection. The conclusion starts out with two parts to it. And it's always made up of first the I learned statement, which is then followed by a my prediction was supported or not supported because statement. We're going to look at the I learned statement first. And in the I learned statement, we can see that it describes what was learned and is related to the purpose of the investigation. And this could be a wide range of things from something that we talked about in class during the Making Meaning conference that occurs usually with the claims and evidence. And that's where the students actually get to communicate with each other and discuss what they saw. And that's the time also for the teachable moment for the teacher where we help them to focus in on what the actual true science is that's going on. And the great part is we can usually structure it in such a way that the students are explaining to each other what's going on, which gives even more buy-in and a more authentic experience to them. We can then also see that they have their my prediction statement, and basically they're saying was the original prediction supported or not. And that supported term is very important because we don't like to say whether it's correct or not because that associates then that it could have been wrong. Instead, we want to talk about supported or not supported, and that's typically how scientists talk about things because they don't want to say whether it's truly possible or not because we can't measure necessarily that it's always possible. Just like with the evidence, we always want to have quantitative data included here. So numbers in their claims and evidence, or in their my prediction statement are essential. If they can have a number in there, we are expecting a number and typically will require that a number be present. After the conclusion, they then have the final reflection part. The reflection is where they look at the I wonder statement and try to say what they think could happen. They ask another question. Is there a chance to try to expand the investigation? And they do occasionally get chances to work on this in class to be able to try these experiments on their own. So basically, it's if we had more time, what would you want to do, or what would your next experiment be? We also then, of course, end with our signature, and this shows the investigation is complete. It allows them to demonstrate that they have indicated that they've done the work and they own the work. A scientist always signs the work at the end, showing that this was their work and they're proud of it. And of course, your scientist should do this as well. And this is always written in cursive, which is extremely important for it to always be there and ready for them when they turn it in. This is again something that's checked when we go then to the rubric to grade. To grade the investigation, we typically do it in a combination of the students' grading parts and then the teachers' grading parts. And we always start out with our rubric, which you'll notice looks very similar uh, to the success guide that you just saw earlier. And in this case, you can see now we have a yes and a no line set up on each one of those. The students will check for each and every item whether it was present or not present. If it's present, they get the points for it, and if it's not, they don't receive any points. You can see here that this student has received points for everything we can see right now on the sheet, except for the procedures and materials they have a no check for. However, they circle that so that it could be reviewed for later. So if there's a concern for something, they can circle it and have the teacher take a look at it and to remind them that, hey, I want to take a look at this one again myself too. It's important though that they review this early because once the papers are fully turned in, after they've had a chance to review it, we don't go back and change grades afterwards. So it doesn't become a constant them trying to look through things. Now, the next thing then after that, after the full investigation is graded, as you can see the bottom of the paper. And down at the bottom we can see the points attained has been written in, and this is the final score that's recorded in the grade book. Both Mr. Woodmiller and myself keep electronic gradebooks, and you can always check their scores on PowerSchool to see the results. We also then circle the letter grade down at the bottom so that way the students know what their current grade would be on that investigation. It helps them out to kind of keep track of whether they got the grade that they wanted or not. The final thing I wanted to draw your attention to is the vocabulary. While this is not part of the actual investigation, this is checked quite often in their notebooks. Vocabulary is typically posted on Monday and then graded on Friday. And both of us have a board in our room that actually shows all the words that we have for this week. And you can see the students have gone through and written the words, and they've always started left of the margin line and then ran the definition over on the right hand side. The definition, it comes straight from the book, and they can just get that from the glossary in the back. They can also modify it slightly into their own words if they so desire. Between each section of the vocab, they'll also draw a line to be able to help differentiate which sections are which and to help them when they are getting ready to study for quizzes. This is a great place to go and review with your students. What you can do to help your students is to ask them questions about what they are learning about. Help them to follow the formatting and make sure the word because is there whenever it is supposed to be there. Using the word because helps them a lot. Also, encourage them to write with examples. So including an example of what they think is going on is always a good way to explain it. When you're helping them get ready for quizzes, you want to ask them about their study guides. You want to try to find out if they're there, if they haven't yet. They usually come out about a week before the quiz, and they can go through them. Go over the claims and evidence from the investigations listed and check out those because they're probably going to show up on the quiz. Ask them about the vocab words. Go over both the words and the definitions so that they're ready for them. Those vocab words will definitely show up on the quiz. And even if they're not listed on the study guide, if they are part of that section, there's a good chance they'll show up incidentally somewhere else. So it's good just to know them. We also typically post podcasts just like you're listening to now for the students to be able to go through, as well as practice questions online and in the back of their book. Both those things are going to be available on My Big Campus, and so your students could actually log on there and check those out when they get on there. At this point, if you have any questions about anything related to this, you can email myself or Mr. Windmiller at Carroll Middle School and include your student's name in the email so that way we can make sure that it gets through to us, especially in the subject line as our spam filters tend to be a little aggressive and lose some of our emails. Again, if you have questions, please let us know, and thank you for watching.